All right, so this is a lot of derivatives and integrals kind of all mushed into one topic. And what we're going to talk about today are parametric equations. Now, I save parametric equations till the end because they're really not that difficult and they play on everything else that we've done throughout the year, except instead of doing everything in a y equals equation, we have an x equals equation and a y equals equation. So basically, a quick overview, a parametric equation is very similar to regular equations, except x and y are both dependent variables that depend on the independent variable t. So you have x in terms of t and you have y in terms of t. Parametric equations are a set of two equations, x of t and y of t, which combined create the x and y coordinates of each point on the curve. Now, if you remember from last year in pre-calc, I know you did a little bit of parametrics then, and that was the one where you changed the mode in your calculator, and then when you graphed it, you were like throwing something and you could watch it fall, things like that. Now, when it comes to calculus of parametric equations, basically all that happens is when you're taking derivatives and integrals, x and y are treated separately, and all calculus algorithms are performed with respect to t. In other words, you're deriving and integrating equations with t in them, and instead of doing it once, you have to do it twice. So, where's my arrow? There it is. Things you need to do with parametric equations. We need to be able to convert from parametric to rectangular. So you have x in terms of t and you have y in terms of t. If you want to get them from two equations down to one and you want it in normal y equals form that you're used to, I would have to say, well, if x equals 3t minus 6, then x plus 6 equals 3t, divide by 3, and you get t equals x plus 6 over 3. Now I can substitute that in here. So when I have y is now t, which is x plus 6 over 3 squared, plus 6t. Now what does that all mean? Basically what that means is if I were to pull up my calculator here, slowly pull up my calculator. If I were to pull up my calculator over here, let me see if I can make it a little bit larger. Medium, that'll still fit, right? Yeah. And then let me just keep this on top. So if I take my calculator and I go to mode, yours looks a little bit differently than mine, but mode parametric, and then I go into y equals, it now says x1t and y1t. And basically what that means is you can type in the two equations and it'll graph them at the same time. So if I have x of t is 3t minus 6, I'm going to type 3t minus 6. And then y is t squared plus 6t. And then if I graph it, I'm going to zoom 6 graph it. If I graph it, there's my equation. Now, why does that look weird? Well, here's why it looks weird. Is because now your window has t-bounds on it as well. So I usually set my t-bounds to go from like, I don't know, -10 to 10 is usually a good place to start. And then hit graph. And there's my equation. All right. So now take a look at that equation. Now I've graphed that in parametric mode. So if I take this, just so you can see it in parametric mode, I'm going to put it right here. And now if I go back into y equals, after changing my mode back to function mode, if I now take that and go back to y equals, and in function mode, come here, no, I don't want you to be drawing, pardon me. If I take that in function mode and type this function right here, let's see, I have x plus 6 divided by 3 squared plus 6 times x plus 6 over 3. If I graph this on the same window, and I look at the one that I graphed in parametric mode and the one that I graphed in rectangular, they're exactly the same. Okay, so basically, there's reasons to use parametrics and there's reasons to use rectangular. In this one, it's kind of 6 of one, half dozen of the other. Now, that's not always the case here, so I can delete this guy. If we come down here, I have x of t equals the square root of 5t plus 4, y of t equals sine t. Again, if we want to get this in rectangular mode, I want to eliminate the variable t. So if x equals the square root of 5t plus 4, then x squared is 5t plus 4. And long story short, t is going to equal x squared minus 4 over 5. So y is the sine of x squared minus 4 over 5. When I come down here, x of t equals secant squared and y of t equals tan t. Ooh, x equals secant squared t. If I try to solve for t here, I'm going to have to square root it and then do an inverse secant. I really don't want to do that. You know what? I'm not gonna. I'm going to say, you know what? If y is equal to tan t, let me try that again here. If y is equal to tan t, then y squared equals tan squared t, right? Well, Mrs. Weaver, why would you square that? Well, because tangent squared is the same as secant squared minus 1. And secant squared is x. So that means y squared equals x minus 1. So y is plus or minus radical x minus 1. Ta-da! Alright, so that's parametric, flipping back and forth between parametric and rectangular, no biggie there. Graphing parametric equations, so if I go back, this is just kind of a step-by-step guide on how to get into parametric mode. You also want to switch your mode from sequential into simultaneous, because a lot of times in parametrics what we really want is to graph two things at once. Yours sequential, simultaneous, there we go. And then get back into parametric. Go to the window and set your t-step to 0.1. Alright, I'll do that too. As long as your t-step is nothing bigger than like 0.2, you're fine. I usually say though t-step being 0.1 is a great place to go. And then when you go into your y equals, you have x of t and y of t. So basically, when we graph these, you have to graph them two at a time, x of t and y of t at a time. And then if I do this one, the piece that I left off before, because we were just trying to compare graphs, is if I were to graph 3 sine 2t, 3 sine 2t, make sure you're in radians, and 1.5 cosine t. And I hit graph here. Ooh, I get that fun figure 8 thing. That's kind of cool. So if I take that graph, I'm going to change my window a little bit here. I'm going to change my window so that y and x aren't so big. So negative 5 to 5, maybe, and y, I'll do negative 4 to 4. So if I hit graph one more time, there we go. Ooh, that's nifty. So if I take this and drag them down over here, the other thing that you need to do in a parametric graph is parametric mode is useful because it shows the direction of motion. So if I watch that graph one more time, if I just type over the 3 to watch a graph, watch where it starts. Okay, it comes down here and then back up and then that way. So it went down here, back up, and then back down. If we want to come over here, let me do it one more time just to give you a better idea here. Watch it one more time. It started from the bottom left, came around, and went back up this way. So if I come back to my graph over here, I started from the bottom left, came around, and then came back down this way. What we do in parametric is we draw little arrows that represent the direction of motion. So now I know this went this way and kind of came around and back down, and it would keep repeating itself over and over again. If I were to do the same thing, do it on your calculator right now, I'm going to save us some time on the time. All right, magically I just put those cubes in while you guys were away. Put it in your calculator if you hit graph again, and we watch it graph. Ooh, this is fun. So this one is a little diamond, and our diamond goes up like that. So it goes, and there it is. So there's graphing and changing the type of equation you have from parametric to rectangular. All right. I'm going to stop this and make a new video just so these files don't get too large.